The future of Victorian infrastructure is green. Recycling Victoria has laid out a 10-year roadmap to a circular economy, a future where our state's public and private sectors will unite to prioritise sustainability. At the core of this are our public assets, the roads and railroads that connect us and ignite possibilities. But where does the change to green thinking begin? The Recycled First policy. Recycled First will require transport infrastructure projects to optimise the use of Victorian recycled and reused materials. This will see the use of recycled aggregates, glass, plastic, timber, steel, ballast, crushed brick, crumb rubber and reclaimed asphalt pavement take precedence over virgin materials. For information, technical advice and support on bringing your sustainable project innovations to life, drop ecologiQ a line. Recycled First, supporting purposely greener infrastructure.
Good morning, everyone, and welcome to our August 2023 ecologiQ Innovation Showcase. So my name is Doy Lee. I am the Industry Manager with ecologiQ, and I'll be your host for today's showcase. My co-pilot is Cheryl West. So in the unlikely incident that anything happens to my internet connection or anything like that, Cheryl might jump in and take over as well. So before we get started, I do want to acknowledge, although we're meeting virtually, that we still meet on traditional lands. So for me, I'm dialing in from the lands of the Wurundjeri people of the Kulin Nations. I'd like to pay my respects to the elders past, present and emerging. I'd like to pay my respects to the First Nations people from the lands that you're dialing in from also, and any Aboriginal or First Nations people that we might have with us on today's event. So welcome. So just for some background, this session is being recorded, and after this event we'll upload it on YouTube, and we'll make a copy of the presentations and all the presenters today. A copy will be made available to you all. So just I know you've made your way here, so I assume you've heard of ecologiQ before, but if you haven't, ecologiQ is a Victorian government program to deliver the state's, and as far as we're aware, maybe Australia's first recycled first policy, which is applied to the big build projects. So those 6 flagship projects that you see down there since March 2020. So the Department of Transport Planning will now also roll out the Recycle First policy. What that means is that for many of you, if you're working or you're bidding for, or you're in the procurement, or you're working on any of these big build projects or future DTP projects, you can expect to have the Recycle First requirement there. And it really is about optimizing recycled materials as part of that step change towards a circular economy. So probably don't need to convince anyone here that, we do have a bit of a waste management issue. So how we leverage the power and the demand for materials from the big build to maybe help mitigate some of that just makes a lot of sense. So while I'm here, I will do a bit of a plug for our upcoming ecologiQ conference and trade show. So if you haven't heard about it or you haven't bought tickets yet, this is your best chance to get in front of and meet many of the suppliers and industry partners that you might see here today. So you see, we've got a huge collection of exhibitors already, but there's still, I think we're expecting over 60 booths throughout the trade hall. We've got tour buses running out to visit manufacturers. We'll have a really quite a big agenda and program in terms of plenary and events. So if you are working in the circular economy space, this is the one conference you should get to this year. So tickets are available right now. Now, helping me for today's showcase, I have assembled an expert panel of senior leaders who are going to give our business and presenters some advice and guidance after their presentations. Can I ask our panelists to switch on the mics and cameras, and I'll introduce them one at a time. Perhaps I'll kick off with Andrew Papakostas, Department of Transport Planning. Andrew.
Thanks, Diane. Good morning, everyone. So I'm Andrew Papakostas, Principal Engineer, Pavements and Materials. One of those areas that I deal with is specification and standards, and that also takes in new materials, innovative materials, and therefore also takes in recycled materials. Thanks, Di.
Thank you, Andrew. Shalini, our own in-house technical manager.
Hi, I'm Shalini, Technical Manager at ecologiQ, looking at reforming of standards and specifications. So work very closely with the likes of Andrew, as well as a bit of R&D and some innovation as well.
Fantastic. Thank you, Shalini. And Irina.
Hi, everyone. My name is Irina Kosteska. My role is Deputy Director Engineering within MRPV. And me and my team are supporting technically all projects and programs within MRPV, as well as ecologiQ, and work very closely with DTP on modernizing and reviewing the standards or updating the standards and specifications for roads and bridge construction, and specifically to include all new trends in construction and recycled materials.
Fantastic. Thank you, Irina. So thank you for making volunteering your time for our showcase and sharing your expertise with our presenters today. So just before we get stuck into it, the whole purpose of this showcase really is a call to action for those of you in the audience. I know in there I've got engineers, I've got procurement people, I've got people from local council to current projects, technical advisories, and everything in between. So we can't, we cannot move the dial forward on industry and see innovations adopted without your involvement and your collaboration. So whether you're an asset owner, you're working in the delivery and engineering space, you're in the design space, we're here to really, and this event is about connecting these sorts of opportunities and the manufacturers of these innovative materials with opportunities that are on your projects, because we absolutely believe that every single project has the potential to catalyze change for the industry. So please reach out is my call to action for people in the audience after this event. If there's anything here that you think speaks to you, or there's an opportunity on any work that you're doing. So now, just to fly through some of the people who've gone before in the showcase event, we've been running these for about 2 years. Here in Victoria, we've got businesses like Orca Civil that make a wonderful material. It's a polymer concrete. It's made with recycled glass and a calcium carbonate. It's been used by Yarra Trams in the city of Melbourne for a number of years now, and you'll be seeing it on the St Kilda Road project. So great local innovation. It can look like bluestone if you need it to, and other materials. So if you're looking for paving or alternatives to concrete, there's one to consider. There's businesses like Omni Group that use coloured glass and other materials to provide safety treatments for surfacing, asphalt. You can see them being used on bus lanes. But really, just thinking creatively for any of the architects and designers out there, you can really use this and leverage this material to activate public spaces. And yes, it does meet the DTP specs under Section 431. So. More recently, we have got Safe Roads that's developed Australia's first T-lock safety barrier. So this is for high-speed safety barricades. These have 4% crumb rubber that's added to it, which actually improves the safety performance of these barricades. So these are available. They've now been approved by not just New South Wales, but by DTP Vic Roads as well. So this is one that's available to market that's come through on recently. You can have green ceramics, so floor and wall tiling that's made from glass and textiles, being used extensively in New South Wales. I'm still hoping to see this come to Victoria. And we have got businesses like CRDC that have, in light of the recent soft plastics issue, have actually set up collection loops and processing centre in West Melbourne to take soft plastics and convert it into a plastic aggregate that they call Residate, which can be used in construction. So. Businesses like Casafico, which work more in the built environment, they take polystyrene, glass, and all your other wastes and convert them to building blocks, leveling coats, and brick and mortar material. You could see it's been used in quite a number of high-profile retail and sports stadiums. And sometimes the innovations are very simple. DuraPanel is simply compressed straw. It's been used in the Olympic stadiums, sound studios at Docklands, sports stadiums, and through compressing that straw, you actually come up with a really solid panel. So, and more recently, we had a business that takes a recovered carbon black from end-of-life passenger tires as a fill material in asphalt, and they pitched at the showcase last November. And earlier in April, actually myself and the team, through the collaboration of everyone here at MRPV, our industry partners and DTP, we are really happy to see that go into the ground as part of a demonstration trial, and we'll be tracking the performance of that. So again, the idea behind this showcase is to see more examples like this. So now, just a bit of housekeeping for today's event. We're going to field 4 presentations from 4 different businesses. I'll kick off with Ma Poiguerrero from Pact Group shortly. For those in the audience, you can ask any questions for your panelists using the chat function on Zoom. Just make sure you direct your question to the panelists so they can find you in the chat and answer throughout the event. So without further delay, Ma, over to you.
Good morning, everyone. How are you? Good morning, Dewey, and thanks everyone at ecologiQ for the opportunity. At Pact, well, we have been present since the beginning of ecologiQ as well. I think we kicked off our own infrastructure solution, sort of spilling all the projects in Victoria and also interstate at the same time. But I'm going to talk today about our infrastructure solutions made from post-consumer recycled plastics. At the moment, our best known project is the Mordialloc Freeway noise walls, which are made from up to 80% post-consumer recycled polyethylene, as I said. Now, Pact Group has 3 different umbrellas. We have the advantage to have a sister company, Pact Recycling, which would be the green area that provides the recycled material that the rest of Pact uses. We sit under Pact Reuse, which is the orange area down there. It's basically everything in the company that is around circular. Well, the whole company is very strong in circular economy, but Pact Reuse is more cyclic products like our Sulo mobile garbage bins that you would have heard of, and more relevantly to the matter of today, infrastructure solutions, and in my case, noise abatement products. The blue is the packaging division that is also centered on the circular economy. If you want to move forward, Dewey, please. So the product today we're going to talk about is our solution for noise walls and cladding and the like. We'll talk about a bit of innovation and what we're working on at the moment. But basically, we have the opportunity to harvest directly from curbside recovery post-consumer polyethylene that gets transformed, up to 80% of what we call, excuse me, up to 80% comprising of half milk bottle grade post-consumer material, so your milk bottles that you will put in your yellow bins, and the other half is a soft plastic. So this blend would get processed and turn into the raw material that then gets blended in with 20% virgin polyethylene and turn into our noise walls. Now, these noise walls all come with a birth certificate. All of our recycled material is fully sourced in Australia. Sometimes we can't guarantee it's going to be in one state or the other, depending on the timing of the project, but we're trying to get better at, sourcing locally, because we can see different state governments are prioritizing that, especially around WA, which is a little bit remote, and sometimes Victoria and New South Wales, we get that kind of question as well. The panels will be very resistant, compliant, and more importantly, fully recyclable at end of life. So the reason we're trying to be consistent in that area is we're trying to make a product that will not only have one more life cycle, but even if it gets damaged, by an accident or after decades, it needs to be replaced. It can be reground and turned into other products like underground pits and other products that we manufacture as well. So being plastic, we can talk about a lot of different design possibilities. If we can move forward, Dewey, I think, yes. So this is what I was trying to explain earlier. On the left, you would see things like soft plastics, stretch wrap that we use widely in industry. For example, our returnable crate service, DPS, a lot of these products, food grade contact regulations are going to require stretch wrap. It's very present and it's really hard to recycle. So we were really satisfied to be able to incorporate it in our blend. And then the end result will be what you see on the right side. Well, your noise panels, and to different degrees of post-consumer and post-industrial material. We also make other products like gas, electricity, telecommunication, underground pits. Can move forward. Our best known, as I said, Mordialloc Freeway project. This is a very lightweight product. So we're talking about 18 to 25 kilos per square meter. This makes, a product that is really easy to handle, transport, it's very quick to install, it's very safe, and it's also very durable. Let's move forward. A little bit on the advantages of the product. So we have been working with different bodies, both in Australia and overseas. This is a product that is getting widely accepted, and as you can see, you'll see it come up in more projects coming up in the next couple of years. The latest one being the Riverwalk estate in Victoria. So if we went forward, sorry. Yes. So we are moving forward in this space in the sense of this is a product with great possibilities, so we can expand the design, intent, even the application. So many projects you'll see, in this case, both designs at the top are the same panel, front and back. So the panels can have a different design on both ends. And as you can see in the bottom, we can cover postings, we can show them different authorities, different project managers will want different things. Some people want a smooth design, some people want to inspect the panels and their fixings. And as you can see at the bottom end, we can imitate other products. Actually, that one at the bottom right, I actually didn't know it wasn't concrete until I started working for Pact. That's just color matching and laser printing to reproduce a panel made in concrete that was already in that area. And we just replaced the section with our product. A little bit further. These are examples of design possibilities. So the advantage of working with molds and plastic, this is a rotationally molded product, is that we can be very versatile and very open to design intents, imitating products. The Mordialloc Freeway one was supposed to imitate Corten steel. There was a bit of a license there using grey panels in combination with the brown. As you can see, the one in the bottom right is the Riverwalk project. That's actually a commonly used in the bottom, a commonly used rectally concrete pattern that we adapted to our plastic product. And we can incorporate, well, our installers can incorporate polycarbonate and other elements if we want transparent products in the file and design as well. But our product is the one at the bottom. Move forward. We are working in different spaces, as I said earlier, so we can see this product being applied to different industries and different applications. We used this product in a manufacturing site that belongs to the Pact Group, to the packaging division that was getting complaints from the neighbors because they started operating after hours. So we provided them with the product, it was set around the factory, and we got actually very good feedback from the factory itself and from neighbors that would appreciate that we were using a recycled product. We want to see this product also in the likes of commercial, real estate, and other industrial applications. Actually, the Riverwalk project I just mentioned earlier is a real estate project. It's a housing project for Development Victoria. Moving forward. This is, again, the Mordialloc project where we use up to 75% recycled. We can do up to 80%, but in this particular design, due to adapting to the architect's intent, they had already designed panels in Corten steel. So we had to make them a little bit heavier for the specification and in this particular case. So it was around 570 tons of plastic that would have ended up in landfill that came directly from curbside recovery. The stretch wrap, as an example, the milk bottle grade, and it was processed and it was repurposed, and it's part of the noise walls right now. We are working with our design team to, different applications that we can expand to in the future. For example, we noticed that there are projects that don't have noise walls, but everybody needs visual protection when they're in a construction phase, like gawk screens, or even noise abating gawk screens that can sit on a jersey barrier, on a concrete or a steel jersey barrier. We're working also on standalone noise barriers for crowd control. And everything we are developing would have the same formulation with up to 80% post-consumer recycled curbside recovery material. We are working closely, as you guys can attest, with authorities and government and state bodies that are passionate about including recycled material in infrastructure projects, both in Victoria, interstate and overseas. We are working with ISC. It says there ISCA, now ISC. We are I-listers, I-supply listers, and we try to get involved whenever there's an event and talk to like-minded people in the industry. this is not a new product by any stretch of the word. So the formulation is quite recent. Before we were doing 30%, but we've been manufacturing these noise walls for over 15 years and they are still standing as the first day. They are really, reliable and a really good solution for a circular economy, being 100% recyclable at end of life. And that would be pretty much it on my end. We are aiming to be the industry leaders in this type of product that we have, we think we have a very good solution for a circular economy, being recyclable at end of life and being applicable to other areas of projects in the future beyond noise abatement, standalone for like big build road and rail projects. This could be also for, as I said, storage areas, service areas and the like. And we are looking forward to working with both contractors, state government, federal government, and anyone interested in a circular economy and in making recycled product the norm and not an exception. Thank you.
Thank you, Ma. It's great to see those panels on the Riverwalk. So yeah, good to see them in the field. I now invite our panelists to the stage for any questions for Ma and Pack Group. Shalini, first want to switch your camera on.
Thanks, Ma. That was a really good presentation. I just wanted to understand what your barriers are right now in terms of the uptake of this really good product. I know that the specification is going through that OS-ROADS harmonization and all of that. And in the interim, we'll actually put that on our ecologiQ website. Is that at all helping you, or do you need more help or more assistance from us in that regard? And is that still a barrier?
Yeah, well, the thing is, it depends on where the questions are coming from. So we are finding that on the contractor end, there's always a champion that is doing some research and finds us and then wants to understand the product to pitch it sideways and upstairs. I guess the barrier comes from people that are looking to, replicate exactly how a competing product, like for example, concrete would work. But we are always happy to, we try to answer questions separately on each technical matter, like, color fastness and UV resistance and things like that. That's going to be, as you said, well reflected in the new specification. But I think the work with ecologiQ has been really helpful because you have sort of vindicated what we've been saying on our own, and it's no longer coming from us. So that's what I would say we really appreciate. And the barrier is really, well, the usual comparing the product to a different substrate and having to sort of debunk all the myths that people have about plastic. But we have the background data to do that. And so far, I think we're seeing really good progress. We just want to see the specifications on the ground, obviously, because some people are saying we won't be moving forward until we have finalized, published specs to refer to and all that.
Great. Thank you.
Thanks, Shalini.
Thank you. Well, stop comparing to concrete. Irina.
Thanks, Ma. Great presentation, and of course, it's very important to mention the boardwalk freeways project success, I guess, in implementing the noise walls. What I wanted to ask you is a couple of things. Obviously, the durability and lifespan of the panels, as well as how can we be sure that discoloration is not going to be an issue, I guess, with this type of product. Maybe you can tell us how that performs, on your product. And the second thing is, what sort of challenges you found by implementing, let's say, the product on the boardwalk freeway that you've learned from and now improved?
Sure. Look, first on the durability and the color, and you were asking about color fastness. The product is a rotationally molded product. So the way that works is there is a powder plastic that goes into a mold that will rotate and go into an oven. Coat the mold, and then you open it and you have a product that is hollow, which is the panel. It's the same way you would manufacture, and we do manufacture water tanks, for example. So the color is in the powder. This product is not painted at all. So if you cut it, if you scratch it, you'll see the same color at the back and inside. This product is actually very stable. It's UV stabilized, And if there's any change at all, it would happen very quickly in the first couple of months, maybe 1 point maximum. It won't change much. It will be very stable, and then it will remain the same for the remaining of the design life, which we expect to be around, I think we're talking about 40, 50 years design life, but really it's anyone's, you know, I think we're doing that to be safe, because, well, everybody's, you know, hating plastic because it lasts forever. And in this case, we're seeing a good, you know, that being a good thing. But yeah, the color is really stable. This product is not painted. It can be. Like you said, we work with Montreal, but we also work with rail projects like the Coalfield to Dandenong bypass, cladding on the bridge. So in that case, for example, maybe I think it was the train authority that said, okay, we don't want to close the lane underneath the bridge. So can we have someone with a paint roller from the top? You can do that, but the product is not painted, so the color will not suffer at all. And it's really, really stable from that end. On the learnings from Montreal, well, you need a supportive team. I think we had several champions on different ends at the Montreal freeway. I think the main thing I want to highlight for everyone is we need to get in the earlier the better. So if we come in early, we can sit together with the architects in the design phase. We can sit together with the engineers when they're thinking about postings, when they're thinking about widths of panels. We can adapt the product to the best suitable solution for everyone. And I think the learning is to try to come in as early as possible, and yeah, to finalize orders and everything, so we can guarantee, you know, in the Montreal case, well, not all the waste would come from Victoria. If we get an order late, then it maybe will come from New South Wales. So if people want local waste, and, you know, the earlier the better, and we can work together with any technical teams to make that happen. Other than that, Montreal triggered some further testing on different ends. It's all been satisfactory, and that's also been really positive for us as well.
All right. Thank you very much.
Thank you.
Thank you. Andrew, DTP.
Thanks, Mark, for the presentation. You indicated the recycled plastic content is up to 80%, and I think you implied that content is a function of the desired shape of the panel that you might need to reduce to get the right shape. So what's the minimum recycled content that you would find in these panels?
I think at the moment, the minimum would stand at the 75% that we did for Montreal. We have also a 30% option. That is an older mold, and that we just have it because, so with this product, once you make the mold, every panel, every size, every sort of iteration of in terms of design of every panel is a different mold. So once we make the mold, we have it sort of forever, and which is why replaceability of this product is really good. If there's a damage, you know, you just put the mold back into the machine, make more panels, send them in a cup, you know, in a matter of maybe hours, a day, days, I don't know, but really quickly. So in that respect, we do have the old 30% mold available if people prefer that design that we already have to save cost, but we are working towards using the 75 and 80% formulations only moving forward where we can. We like to keep that 20% sort of skeleton in virgin for sort of consistency, and so we can be confident that, you know, it will be consistent in terms of testing and the product. We're trying to be, people think that recycled product can be inconsistent sometimes, so we give ourselves that leg room of the 20% to make everything sort of tie all the material together and make it consistent and, you know, sort of comparable from one project to the next. But yeah, I would say the 75%, 80 mark is what you can expect in the future.
You mentioned the panels on PenLink, and PenLink's been around for some time. The technology used in those PenLink panels, how do they differ to today's panels, so that you use PenLink?
So the PenLink panels, the fixings and everything were designed differently because we had to adapt to a request that we probably wouldn't do today. And also the recycled content. So the recycled content back then, I'm not even sure what it was because it wasn't a requirement. We started doing recycled material basically because we could do it. We have Pack Reuse next door. It's the same company. And we saw it as a point of difference that could help us. But back in the day, we would include maybe 30%, maybe nothing. Maybe it wasn't really a request. So the project, Penlink, we like to show Penlink in terms of, I personally think it's a really good example in terms of design, how you can play with, the letters, the logos, the colors. It's very striking. But the message is we can, do something similar with the newer, more modern product in the newer sort of higher recycled content formulation that we use nowadays.
Yeah, and just on specifications, I do believe the Australia's technical specification for plastic noise walls has been published. So if anyone's got any interest there, they could go to the website. Thanks, Ma.
Thank you so much.
Thank you. Thanks, Ma. Ma, I think there's a couple of questions for you in the Q&A. If you want to hop in there and answer those just in the chat function. And for the audience, any questions, please ask your questions in the chat function under the Q&A, and our presenters can answer them at time. So thank you, Ma. Moving along to our next presenters, we have James and Brendan from Closed Loop and PackPave. Talking about PackPave, sorry. James.
Good morning, everyone. Thanks, Doy. I also wanted to first begin by acknowledging the traditional custodians of the land which I'm calling from, which are the Gadigal people, and pay my respects to their elders past, present, and emerging. I'm a project manager at State Asphalt New South Wales, and I've been looking after our sustainability projects for the past few years. Brendan and I actually presented here a couple of years ago at one of the first ecologiQ showcases. And we've come some way since then.
Yeah.
Today I wanted to talk about our collaborative partnership to develop construction materials from waste, but more specifically, more about a product that we brought to market called PackPave Fiber. So the agenda today, give a bit of background about who we are, the problems we're trying to solve. I'll do a walkthrough of the product and then where we're heading. So State Asphalt New South Wales, we're a family medium-sized business based in Sydney. We got in the construction space about 50 years ago, working on projects like the Hume Highway, Sydney Airport, and about 20 years ago, we got into asphalt production and laying. And we now supply asphalt throughout metropolitan Sydney and Greater New South Wales. And in 2020, we built a partnership between 4 private companies and a university. So that's ourselves, as you mentioned, Closed Loop Environmental Solutions, Asphalt Tech, Primaplus, and the University of New South Wales. And we set out to solve some pretty ambitious but particularly challenging problems in the waste and recycling space, which is composites and mixtures. And so I first wanted to size the problem and give you some statistics about paper and cardboard recycling. So this market's already really quite circular. There's really good collection, really good robust sorting infrastructure, high recycling rate, healthy end markets, but that devil really is in the detail. And the key word here is average, and that doesn't really tell the whole story. Next slide, please, Dory. So the problem with averages, and apologies for this old data, it's from 2013-14, but the problematic waste stream we're looking at is liquid paperboard, and specifically what's affectionately seen here as hot cups, but as we all know them as takeaway coffee cups. And so like a takeaway coffee cup, it's an incredible feat of engineering, really. It's a 300 micron paper laminated to a 25 micron layer of low density polyethylene. It weighs 10 grams. It holds 50 times its weight of hot liquid without disintegrating, and it's all food safe. But really, it's these properties that make it kind of functionally impossible to recycle those components. If you delaminate that plastic, you get 0.7 grams per cup of LDPE. If you recycle a paper, then you're putting plastic film through a pulping plant. There's blockages everywhere. And so it's these properties which make it lightweight and liquid safe. But when you compare this recycling rate compared to, say, like traditional paper and cardboard, the recycling rate is missing at 0. And of the 50-odd thousand tons that we consume per annum, if we look at what's actually locally recycled, it's really low, and we want to make a dent in that 0. Next slide, please, Dory. So what is PackPave? All right, it's our initiative to make dents. It's our ambition to materially increase the recycling rates in these problematic waste streams. And we're very much like a first principles approach kind of company. We want to solve these hard problems first. So in the case of PacPave fiber, it's reverse engineering liquid paperboard coffee cups, knowing that it's a cellulose fiber and a film grade LDPE. So some facts: we know that we use cellulose fibers in stone mastic asphalt or SMA. We know that paper is cellulose, and we know that our plastomeric PMBs in binders use polyolefins. And so as a side note, for those who don't know what stone mastic asphalt is, there's an absolutely riveting primer coming up. So the second part of our approach is collaboration across industries, and we're really just lowly asphalt guys. Before this project, I had no idea what polyolefins were, let alone sort of the difference between a 10 melt flow LD film grade and an L metallocene that has a 2 melt flow, but our partners do. And I know that it makes a difference in our asphalts. And so really recycling is an exercise in materials engineering, and we need that collaboration across different subject matter experts, across different material types. And so that's why we're so passionate about partnership.
Yeah. James, just letting about 5 minutes left to present, so I'll...
Okay, we'll just sprint through. And so Brennan was like, actually, I should really talk about the product at some point. So why don't we get through and sprint through to that. So when we get to PacPave fiber now, we actually built a quality assurance system for sorting and collecting coffee cups. We have closed loop that now has 1,500 collection points nationwide, and they now have an Australasian recycling label as a qualified recycling system. We have a partnership that covers end-to-end from coffee cup collection through to finished asphalt pavement. And these fibers are being produced locally, and they're commercially competitive with existing fibers. Next slide, please. So the primer and SMA, sorry, there's an animation. Can you click again? Thank you. Stone mastic asphalt, stone on stone skeleton, high compressive strength. Using fibers means you get more bitumen, which means higher film thickness, which means better fatigue, better waterproofing. You just end up with a much higher performance asphalt. There's better surface drainage, skid resistance, noise suppression. And so really sustainability for us is about making sure that we don't jeopardize the circularity of existing asphalt. And so we're trying to balance three things here: recycled content, carbon intensity, and durability. And by promoting something like SMA, we get the chance to use novel beneficial additives like fibers from local waste. And our PacPave fiber is 100% recycled. At a usage level, it's about 400 cups per ton. And it doesn't seem like a lot, but when you stack it up in aggregate demand, liquid paperboard looks like a pretty good supply. In terms of how we manufacture it, we want to ensure that we're not changing any of the traditional models of manufacturing. Asphalt manufacturing is quite an efficient process already. A modern plant is exceptionally efficient, and we don't want to have to build new ad lines or new novel technologies just to introduce a new material. Next slide, please, Dylan. So where are we today? We've laid about 400 tons of SMA. Or actually, the next one was probably better. Thanks. We've laid about 400 tons of SMA using PacPave fibers, so a bit over 150,000 coffee cups that have been recycled already. Both Transport for New South Wales and EPA have been co-regulators that have overseen the approval of our product. To my knowledge, they're about the most stringent in the country. We have a commercial scale production facility, and we're looking at demonstrating on an IS Council rated project later this year. And just to be sure, the pavement trials have gone really well. We've actually trialed a really aggressive thickness reduction using SMA because of its increased performance, going with a 30 mil SMA 10 compared to a 50 mil spec AC14, and it's holding up really well. So next slide, please. So the next frontier for us is, as I mentioned, hard problems first. It's three things. It's expanding our collection of hot cups through the SimplyCut network. It's secondly looking at additional liquid paperboard streams like aseptic containers and gable tops, that's long life milk and milk cartons respectively. And thirdly, it's replicating those production lines across our partner network. And so our goal is to kind of keep it local and modular. If you take an interesting consideration, if you transport 1 ton of material from Sydney to Melbourne, that's about the same amount of carbon intensity as making a ton of asphalt, which means drying and heating aggregates and bitumen to 170 degrees. So keeping it local is something that we're really trying to accelerate. And so, yeah, I want to preface this. I wanted to talk about pack-based fibers today because I'm here with my partner, Brendan Lee from Closed Loop. Yeah, we were co-presenters last time, but we've actually been looking at a whole bunch of other materials as well beyond pack-based fiber. I think pack-based fiber is going to be our first of many. We're basically trying to look at Australia's national waste priorities being glass, paper, plastic, and tires. And on that note, I'll turn over to Q&A.
Thank you, James and Brendan. So Irina, first one to on stage. Over to you.
Thanks, James. Look, it's great to see that yeah, you're trying everything to use local products and utilize especially the coffee cups because we're very fond on those in Australia. So my question is really more to understand what do you see as barriers, I guess, for the industry kind of within the industry to utilize this product, or do you see this as a business as usual now, and or you look for other challenges? So what can we help you in terms of the major infrastructure projects to promote this product?
Yeah, so I think the two parts to that would be at a technical level increasing our technical expertise across different procurers. Going to something like a stone mastic asphalt is quite a technical endeavor. And so understanding the benefits and the properties and doing that whole of life understanding of, okay, well, if I use something that's slightly more carbon intensive, the trade-off is that I use way less of it and it lasts longer. So there's a huge amount of promotion of sustainability through durability is where our focus has been. So there's the technical aspect of that. And then on the other dimension, it is becoming business as usual for us. That's exactly what we're trying to do, is build these commercially competitive waste-derived materials without having to completely upend our supply chains.
I mean, from my knowledge, stone mastic asphalt is not always used. I guess I don't know what the difference is between New South Wales and Victoria, but if it's used, I guess there are no obstacles from a standards and technical point of view to use it, is it?
Yeah, that's exactly it. We wanted to ensure that our product was a drop-in replacement. We're not sort of adding an additional material type into this existing composite that is asphalt, that we're replacing an existing material and substituting it with a locally recycled material.
Okay, thank you.
Yeah.
Could I just add to that too, Irina? Because thanks for the question. And you're talking about sort of what sort of obstacles are there and how we can break those down. I think one thing is, because this product's being developed in New South Wales, we've been very clear about the regulatory process there that's required, and so this has been highly scrutinised by the EPA and Transport New South Wales, and so the development of that has really been guided by that. We believe that now sort of replicable. So the uptake in Victoria and other states should be fairly simple in a regulatory sense and a technical sense. But if you're able to help us understand how this can be, I guess, certified or whatever as an accepted material, then that would be very useful. And James, I don't know if you already have information around this.
So from a technical aspect, I think it's just ensuring that we have transparency across what we do in terms of performance data, environmental test data, and sharing that across. I mean, that's part of what we've been doing, is that transparency. The timeline's been quite long for product development because we want to make sure that it is robust and that we can stand by its performance. That's been part of that engagement with Transport New South Wales from their pavement technology team, and also the resource recovery team from EPA in New South Wales. So I think a lot of those data will be directly transferable to different regulatory jurisdictions.
Oh, you're on mute, Irina.
Sorry. Thanks, Brendan and James. Maybe Andrew can help you with some comment here in terms of acceptance, I guess, of this product or this mixture. Thanks.
Thanks, James, for the presentation. So fundamentally, in terms of the pack paving, the difference is it's the fibre added, it's the additive. That's right. So stone mastic asphalt, great product, great surfacing. We use a lot of it.
Yeah.
So in terms of the additive, we in Victoria require essentially 100% cellulose fibre. Your fibre contains a proportion of...
It's about 10% LDPE.
Yeah, and I think that plastic proportion changes a bit depending on your supply. So that's okay. So in terms of a way forward, then you'll be approaching DTP because you've got something that's non-conforming.
Yeah.
We know that the fibre has a role in drain down of bitumen. We can test for that. We can see it when you place the stone mastic. So there's a way forward. The next step for you, James, is to contact DTP and come in and have a bit of a chat.
Yeah, that's been a huge part of our test, our product development, is ensuring that we get reliable drainage or drainage management, I should say, making sure we have all the performance data for it as well. So yeah, I'd love to reach out.
No worries. I haven't got any more questions, so I think you're pressed for time. So thanks, James.
Thank you so much, Andrew.
Shalini.
Thanks, James. That was a really good presentation. I think my only question is around the end of life recyclability. If you can just give us some context.
Yeah, so that's I think I probably didn't time myself very well today. So part of our framework is sort of making sure we don't really change the existing composition of asphalt. Is that if we've got fibers, cellulose fibers in stone mastic asphalt, and we've got ethyl vinyl acetate in our A35P P&B binders, I mean, we're not fundamentally changing the stuff that goes into it. So making sure that we don't jeopardize that circularity, making sure that we do all the microplastic testing, making sure that we do all the leachate testing. We did a really comprehensive PFAS study on this post-consumer material as well. It's really following the RMIT Australia's guidelines as well around that compatibility framework for polymers, because we know that it's a mixed material. That's why it's hard as a composite. So yeah, I'm more than happy to share some of that data as well around end of life and the abrasion data that we got.
Great, thank you.
But it'd be fair to say, James, wouldn't it, that pack pave is recyclable into...
Sorry, yeah, the one-liner after that barrage is yes, it's recyclable after at end of life. It's standard asphalt.
Perfect. Thanks.
Thank you, Shalini, and thank you, James and Brendan. Looks like we have a bit of homework to do, so we'll organise that catch up with DTP after this to commence that approval process. James, Brendan, there's a few questions for you in the Q&A if you want to hop in there and answer those about pack pave. So thank you for your presentation.
Thanks, Dory.
Thank you. Now, Philip, something a little bit different. Tell us about TrueGrid.
Thank you. Thank you, everybody, for attending this morning. I guess the real question that I'd like to ask is, how do you integrate a sustainable solution for managing stormwater volume into urban design and break down the silos such as predefined singular policy that doesn't facilitate integration? So that's a starting point. Next slide, please. So everybody's had an experience with permeable pavers to date. Basically, they are pushed for flood resilience, urban heat resilience, and urban green infrastructure. But of course, they're expensive to install, maintain, they break down, don't carry loads, and of course, they clog over time. So what makes TrueGrid different? Next slide, please. TrueGrid is manufactured from 100% recycled HDPE and is 100% recyclable. It is manufactured from post-industrial single-source water and infrastructure pipes, such as mining pipe and the like, cleaned, granulized, and injection molded into the grid. And the grid has a 40+ year lifespan in the ground. UV stabilizers are added, but at the end of its life, it can be reground and reused into other aspects as well. Next slide, please. It's all about how you take a pervious surface and detain stormwater below. In most instances, the stormwater infiltration from permeable pavers might be 2 or 3%. We are, in essence, 100%. So you're able to detain the amount of volume of water below the grid based on the use of a angular gravel, which generally has a 40% void space. Next slide, please. So water quantity and quality. So it's quite easy to work out the detention capacity of TrueGrid. It's based on using a 20 to 25 mil angular gravel, which has a nominal void space of 40% to sit below the grid. And so it's quite easy to know how much water you can hold in that base. It has a flow rate coefficient of 0 to 0.05. So the aim is to capture all the volume on site and have no flow off site. The water flows below the surface in the angular gravel. And with water quality, I'm pleased to announce that we've now completed a music node for treatment with various options based on the type of subgrade that you put below it, which will allow you therefore to treat the stormwater as well as part of your car park or other facility. Next slide, please. So you can have gravel, stone or grass infill, all operate in the same way. I originally brought the process in for grass car parking, where you don't want to crush the roots and you want to have longevity, and it delivers that quite simply. Next slide, please. Structural integrity, being a builder and developer, for me, it's got to be practical. So we base the recommendations on a CBR table, and the CBR determines the depth of gravel in the subbase. And you'll notice by the table to the side that the field compressive strength is over 17,000 PSI. So it's categorized in the US the world's strongest permeable paver, but it can carry any load. In fact, I've got a project at the moment where we're about to put a D11 bulldozer on it. Next slide, please.
In this cross section, you can see the benefit of utilising.
Oh, how did that happen? Sorry, you got double.
Capture.
I got audio happening at the same time. Sorry about that. So in the cross section, obviously, we're managing the stormwater in this place. Go to the next one, thanks, Stu. I don't know how that happened. In a comparison cross section, you will see that the difference between putting TrueGrid concrete and asphalt. With TrueGrid, you also don't have the pit and pipe infrastructure. And because you have a zero flow rate, there's no GPT required. The pollutants don't get concentrated in the process. The permeable pavement detail and the asphalt pavement detail on the right-hand side of the screen are for a job in Victoria, where you can see the difference, ease of laying, ease of contracting between the two surfaces, and these surfaces actually abut each other. Next slide, please. As I said, can carry any load, temporary or permanent hard stands. The aim is that you drive on the plastic surface, you don't drive on the gravel, and therefore there is no dust created, no water ponding created, and the site becomes virtually maintenance free. Next slide, please. Tree protection zones, we do quite a number of these. This particular project at Queensland Airports and McNab is for a food industrial warehouse. And you can see by the cross section that the concrete slab, which is 200 mil thick, and the TrueGrid, which is 48 mil thick, carry exactly the same load. But in this case, they used the permeable area to feed water into the tree on the neighbouring site, allowing them to have 100% land utilisation. And the same vehicles drive over this surface, whether in terms of semi-trailers and trucks and the like. Next slide, please. This project, some of you will be familiar with, the Avalon Beach boat ramp upgrade for a better boat in Victoria. I've added the picture on the left because that is the grid being laid at this time. So the reason for this particular project was that it had to sit right next to the ocean. It had protected vegetation all around it, and it sat on the salt flats. So how do you construct a treatment basin? Well, the way in which you do it here is you capture all of the water inside the car park itself, and you treat the water prior to it leaving the car park into the vegetation or the ocean. Next slide, please.
So to recap, TrueGrid plastic group.
Oh, sorry, mate. I don't know how that happens. Sorry, Duke.
Central uses. You can have grass or gravel fill
Do you want to?
reduces flows, retains stormwater below, reduces pollutants, can provide root protection and infiltration outcomes, and can reduce the impact of urban heat island effect.
There you go. You can catch your breath, Philip.
Yeah, that's right. I don't know how that got in. So that's me. I mean, really, the question I'm here to ask, like everything, is how do you obtain trials? How do you obtain projects where there is no Australian standards related to permeable pavers? Doesn't matter whether they're brick, concrete, or otherwise, and there is no regulation for this type of product, where in actual fact we're not considered a pavement. So that's the assistance that I'm looking for at this time.
Thank you, Philip. So very succinct presentation, but I think yeah, great product. I invite our panelists to the stage. Does anyone want to take the floor first? Irina.
Thanks, Philip. Look, I can see that this product is already utilized a lot, and that's great to see. You know, in terms of where else we can use this product, and especially for the big build and major projects. I guess, let me ask first a few questions. What sort of maintenance is required for this product, or should I say the paving? Because you said it's a 45-year lifespan, but the gravel that is filled in, I mean, does that need to be topped up or, you know, leveled over time? And, you know,
Yeah.
what's the...
It was a 40+ year lifespan, sorry. It was 40+ years, right?
Yep.
So it's exactly the same as using a infrastructure water pipe or the like, which you put in the ground with an expected lifespan of 100+ years. So it's the same product, single source HDPE. So when the gravel is filled to the top, and because you don't disturb the gravel, you drive on the plastic, basically the maintenance is zero. So depending on the type of car park that you wish, so if you have a NDIS compliant car park, we use a 5 mil gravel fill. If you have a commercial car park that has to be high hill friendly, use a 12 mil gravel fill. And if you're using an industrial yard, you will use a 19 to 20 mil gravel fill. The gravel doesn't come out, it doesn't move, because in effect you're driving on the plastic. So in the car parks that we've done for major clients in Queensland, sports clubs and the like, they've been down for 5 years, and the total maintenance in 5 years has been 30 minutes. So the ongoing maintenance cost for this type of project is far less than asphalt. The install cost should be the same as asphalt, if not less from a starting point, and certainly cheaper than concrete. But in terms of the projects that we look at, and most of the clients that we see today, they're looking for a response to their ESG policy. How can I take an area that I was going to create a car park and be able to manage the stormwater that flows off roads or bridges or those sort of areas? How can I capture that water in something that is usable so I get another use for the land, if that makes sense?
Yeah, and you've mentioned the treatment, the water treatment, and you've used music model. So are you kind of relying on the layer under the true grid to filter the water and to purify it, and what sort of filter media you're using there kind of to make that happen?
So the true grid, to form a stable road base that can carry any load, like any engineered cross section, the angular gravel is what gives it its structure and its strength. So when you come to do a treatment node, the angular gravel at 20 mil is too large to have great filtration properties. So we use a coarse sand and gravel mix, and that reduces the filter node. So yes, it is part of our structure. You can make it as deep as you like, because angular gravel doesn't compact over time. You can make it deep as you like and add more depth to get more storage or more treatment. The results show that by using a 60-40 mix of angular gravel and coarse sand, you generally get to about 80% of nitrogen and phosphorus, and obviously all your gross pollutants are taken out. So it is part of the treatment train, but it is able to deal with the majority of certain outcomes required and reduces any need for detention or treatment basins at the end.
Would that need some form of replacement of that sand or the treatment media over time? Because obviously 40 years is a long time with no replacement.
Yeah, so the difference here is that in the normal filter media, you've got a very slow flow rate and a very small void. When we do a sand gravel mix, the void is still 16%, and the void is large enough over large car park areas that you can't fill it. For example, if you just used angular gravel over 1,000 square metre car park, you'd have 240 cubic metres of void. So you've got 240,000 litres of water. So you don't see the need to clean it. There's no clogging as such, which has been historically a problem with permeable pavers, because the extent of the void is so large. And if you have any pollutants or otherwise that fall on the gravel, generally what happens is microbacteria eat it because it's captured in the gravel and it doesn't get washed through. So there appears to be, on all the testing, because this product was invented in the US, on all the testing, there has been no reduction in flow rates over time, given the size of the void is so large.
Okay. And you said you see obstacles in terms of not having standards, I guess, for this type of pavement. I guess it all depends on what sort of specification the client would like at the end of the day,
Yes.
in terms of the type of surface that they prefer. I mean, I'm sure that you have enough evidence how this performs in terms of the loading and kind of durability and everything else, which can be, I guess, proven. But it's more about, you know, what sort of surface is required, I guess, at the end of the day. But yeah, I don't have any other questions. But if you have specific kind of requests in terms of target particular standard, yeah, maybe you can put together some proposal on that, because specifically for the treatment, for example, of the water, I would say you need to talk to local councils and others who need to accept that as an acceptable treatment area, rather than introducing something else, and then you can save on that treatment on the side, I guess, you know, that you would have done elsewhere.
Yeah, but that's what music does. So most councils accept music. The real question is, how do you tie it to a project where you want to deal with the water? So the last thing we do in roads and bridges and big build is we forget about where the stormwater is going to go and how do we deal with it. Yet, if you look at some fantastic, innovative, you know, sustainable projects, very large projects, and the thing that they then go and do is put an asphalt car park outside. And the asphalt car park has CO2 emissions and urban heat island, all of these sort of items. So it comes down to, how do you extend the sustainability of your large project across to the last thing, which is always the car park. So how can you get a green star for making a car park green? And that's what we're about. How do you create a sustainable commercial car park?
Okay. All right. Thanks for that.
Thank you.
Thank you. Very in-depth. Shalini.
Thanks, Philip. That was really interesting. I just wanted to find out, are there any limitations? Say if you've got you know, refineries or petrol pump stations and the oil drainage that's coming off that, how does the product actually deal with some of that?
So you contain it with a geofabric. So you still contain it within the substrate with a geofab that has a non-woven, non-infiltration geofab, and you can then capture any of those contaminants and take it to a pit and then deal with it from a pit.
Great, thanks.
Yeah, thank you.
Thank you. Andrew.
Thanks for the presentation. Your product is reliant on a system. It's not just the paving product, it's the aggregate, it's the depth of aggregate, etc. So presumably you would require the structure to be constructed to normal roadwork specifications, but you would get, I suppose, play a part in ensuring that what your product is placed on meets your requirements.
That's why we run it to the CVR table. Yes. So any engineer, as a builder and developer, it's always about, can a licensed engineer in Queensland sign off on the design? And that's where we start. Yeah. Right.
And your question about specifications and standards, you're right. I can't think of any specification standard relating to the design of permeable pavements. I tend to deal with heavy traffic roads, and we don't really get into that space. And I think, in a sense, your product is about where there's a desired design outcome, where we want you know, to capture that water. We're concerned about trees, etc. And what's the solution that gets us there? In a sense, it could be about your product, people having a high awareness of your product being available, such that when they're in that space and they're talking about those desired outcomes, they're aware of the options. That it's not just about permeable asphalt or permeable concrete. It's about potentially placing your product in another design system. So maybe it's the challenge there is increase awareness.
Well, that's what we try to achieve. But yes, it is, because it's a technical product. So we do landscape architects, landscape designers, engineers, and the like. One thing that we get is, yes, the angular gravel structure is something that complies with a normal main roads design.
Yep.
And then we put the grid on. And because I say the idea is that you drive on the plastic, because on the top of the rings, because it's flexible and that stops the dust and like, they go, well, then it's a pavement. But it's not a pavement because the structure is the pavement. And so that's where the debate ends up.
Yep. Thank you, Philip.
Thank you.
Thank you. I'm just having a quick scan. There's no questions for you so far, Philip, from the audience. But if there are any, please pop it in there. So yeah, so my takeaway from that, I'm not sure if you do need a specification or not. It sounds like the design intent and outcome is probably the starting point for your product. So hopefully there's someone in the audience there that's trying to not just meet the Green Star S ratings, but actually trying to mitigate some of these other issues with their car park. So thank you, Philip.
I was too quick for you. Thank you.
Not a problem. Feel free to remain online. You never know, there might be some questions popping up as we go on. So thank you. Now, next, I now invite Paul Abram from Integrated Recycling. Paul.
Thanks, Doy. Good morning, everyone. Thanks for having me along. Especially thank you to ecologiQ for their continued support. It's we've come a long way with the help of ecologiQ over the last few years. I'm the sales manager at Integrated Recycling. I'm just here to give an overview of what it is that we do and the products that we provide. So it's relatively formal, so I don't miss anything. So Doy, if we could go to the next slide, please. At Integrated Recycling, we take redundant Australian agricultural, industrial and consumer plastics and produce a range of products that are tough and durable. Products aimed primarily at outdoor applications, and over the years we've progressed from servicing your local council with our Parkscape products to developing engineered infrastructure products for the transport sector. Integrated Recycling is part of the ProPack Packaging Group, which is a leading manufacturer of plastic film products. And it's many of these products that we repurpose once they have come to the end of their service life. And our aim is to bring what was considered formerly redundant waste, plastic, into the circular economy to be treated more of as a resource. Next slide, please, Doy. So polytensilate is the name of the material which we make all our products from. We develop polytensilate so we can engineer products of scale for industrial and infrastructure applications. Australian recycled plastic makes up approximately 85% of the polytensilate mix. We believe this innovative and resilient material is now part of the solution to Australia's waste plastic problem. The high performance and versatility of polytensilate allows us to address a wide range of product applications in infrastructure, construction and landscaping. It won't degrade in the environment from rot, pests or sun damage, giving it great longevity in the harshest of conditions. Next slide, please, Doy. So our primary source of plastic is from the agricultural industry in and around Mildura, where our factory is. The main local produce is table grapes, which need to be protected from the elements. And this protection is done with vine covers that you can see in the photos on the slide there. These covers get used for about 12 to 18 months before they reach their end of their usable life. And then the growers roll them and we pick them up and take them to our factory where they're processed, ready to be made into new products. And from that, the local Mildura area, we also process other polyethylene-based plastics like irrigation pipe, water tanks, grain bags. We also use polystyrene in our polytensilate mix. And while the majority of plastic is sourced locally, we are now being offered clean, high-grade plastics from further afield, with plenty of companies who are willing to deliver their waste plastic directly to us in Mildura, which is pretty amazing considering that, you know, it's quite the cost to transport this stuff, but the sustainability aspect of what we do is really sort of, people want to be part of that. Next slide, please, Doy. So the Parkscape range, this is where our story really began. We've been supplying our furniture and bollard products to customers like Parks Victoria since about 2010. As our Parkscape range grew, our products proved to be a great investment due to their longevity and the fact that they barely need maintenance. They easily outlast traditional timber materials, and they're ideal for national parks and more remote locations where regular maintenance and inspection is difficult. The Parkscape range now includes a wide range of customizable bollards, boardwalks, and a retaining sleeper system, which is backed by engineering and testing carried out by the University of Melbourne. So now that there's a greater emphasis on sustainability in most projects, these tough and durable projects provide both a long service life and those sustainability credentials. Next slide, please, Doy. So we have a noise barrier wall, which we developed in conjunction with the geotechnical engineering team at the University of Melbourne to test the modified polytensilate formulation as a structurally sound and lightweight panel that inhibits the transmission of sound waves. It's tested with excellent results in both the field and in the laboratories of Uni of Melbourne. The lightweight panels have been assessed for noise transmission loss, fire resistance, UV resistance, and the ability to sustain mechanical loads. It's a simple solution, uses lightweight sleeper style panels that are designed to work with a standard I-beam product. You can see in the photo there that we've got two workers just slotting the beams into the I-beams. So that picture there is our sort of the first test example of the noise wall, and it's performing really well for sound attenuation. We're hoping to start a project in the near future with Queensland Rail. We're looking for it to do a bigger proof of project in Queensland. So we're just looking for a suitable site to do that. Next slide, please, Doy. So the DuraTrack sleeper is one of our favourite products. The development of a recycled plastic rail sleeper was initiated by Public Transport Victoria in 2014, and we modified our formulation to meet the performance requirements of the rail industry. During that development, I collaborated extensively with the Institute of Railway Technology at Monash, and for that matter still does, for testing and analysis. In 2021, the DuraTrack sleeper was type approved for slow speed applications by both V-Line and Metro Trains Melbourne, and we have ongoing in-track type approval trials with Queensland Rail and with ARTC. So over the past 12 months, approximately 1,500 broad gauge DuraTrack sleepers have been installed on several V-Line regional rail revival projects in Victoria. DuraTrack railway sleepers deliver a closed loop recycling solution. The load bearing capabilities of this product have worked really well with the application, and we use between 64 and 99 tonnes of recycled plastic per kilometre of track installed, and so DuraTrack sleepers are easily recyclable at the end of their service life, as they don't contain glass fibre or steel reinforcing. So at the end of their service life, they can be reprocessed into another sustainable project. Early versions of the DuraTrack sleepers have been used on tourist and heritage railways in Victoria and WA since 2015. The design life of the DuraTrack sleeper is 50 years. and we currently make them in 2 cross-dimensional sizes: the Queensland Rail narrow gauge, which is the 230 by 115, and the Metro Trains and B-Line broad gauge size, which is 250 by 125. We continue to explore new uses for our products. With our extreme durability, we're now attracting opportunities where traditional materials like timber have been used through generations of purchasing habits, but the tough, long life attributes of polytensilate now allow customers to benefit through whole of life cost savings while achieving sustainability targets. No matter the application, polytensilate provides a long-lasting solution that is rot, pest, and chemical resistant. It's an Australian-made product that uses only Australian waste plastic. Next slide, Doi. A few final statistical little bits of information. A kilometre of rail using Duratrack sleepers would use at least 64 tonnes of waste plastic and would save approximately 150 trees. And for the noise wall barrier, a 250 metre long noise wall barrier at 3 metres high would use approximately 40 tonnes of waste plastic. So it's something to think about it. So thank you, and please, any questions?
That was our final presenter, Shalini. Trigger finger.
Thank you, Paul.
Hi, Shalini.
Hi, that was a really good presentation. Just in terms of the Duratrack sleeper that you've got, any plans of expanding it to a high-speed rail network?
Yes, there is. So that's the next project that we're working with Monash. It's the Gen 2 sleeper. So we're looking at getting a sleeper that will take the high-speed rail, and we're looking at the types of reinforcement that will work with that, but we'll still be able to ensure that the sleeper's still going to be recyclable at the end of its service life. So it's finding that balance of the correct stiffness, but still be able to recycle at the end of it, so we can maintain that circular economy.
Great, thank you.
No worries.
Thank you, Shalini. Irina.
I don't know if I missed that, but what sort of percentage of recycled material would the products would have, and might be different for the Duratrack versus the noise?
No, it's actually pretty much all the same. It's generally 85% approximately is the recycled plastic content. The difference between say for the Duratrack and the Parkscope products, we have a higher content of high density polyethylene, so a higher HDPE content. So that's the sort of main difference between the two, but the full range is about 85% recycled plastic.
And another question, not sure if you're familiar with the specification for the noise walls that was developed, and how would the product comply with that specification? I don't know if you tested it against that.
Yes, we did.
Yeah.
Sorry. Yes, yes, we did. We received that. We've got the noise wall specification that was done by Vic Roads, which was released a couple of years ago. So we've worked on that one, and we've actually got we can provide basically a tick box that goes through each layer of specification and how our retaining wall sleepers perform against that, and in generally we tick most of the boxes on that one, so we sort of built it around that specification.
And I assume the noise walls panels were also fully recyclable at the end of life?
Yes, that's correct. Yep.
Okay, all right, that's all from me. Thank you.
Good, thank you.
Sarina. Andrew.
Thanks, Paul, for the presentation, and well done on developing such a product range and the technology.
Thank you.
That photo on screen, I think it's Richmond Station and Duratrack.
Yep.
So leading up to that application, you would have done a lot of lab type testing to demonstrate to the client they'll go the distance. I think that was installed some years ago.
Yep.
what ongoing monitoring would you do, say, of that particular site to get build confidence with clients that's going to go the distance?
Yeah. So with that one, it's really just the visual monitoring, same that as you would with the standard sleeper. But we do have an installation that we've done with ARTC that has that Monash Uni have got sensors, and it's been collecting data for probably since I think for the last 2 years. So that's an ongoing thing. We just took on a new amount of data off that site in March of 2023. We've just gone back to Monash University. So there is constant monitoring available now in a couple of sites.
Any thought of taking one of those tracks and taking them back to a lab and doing those tests you did on a new sleeper to see what the remaining life might be? Is that?
Yeah, that's something that will be done. I don't think we've done that yet from any of the sites, but that will be done. So it's always a learning process to see, how they're performing. But there's certainly no indication that there's any faster degradation of the sleeper or anything unexpected so far.
Thanks, Paul.
All right, thanks, Andrew.
Thank you, Andrew, and thank you, Paul, for being our final presenter. Now, I'm pretty certain that's between platforms 2 and 3 at Richmond Station.
That's right. Yeah.
Yeah. So if you're down there, next time, have a peek. You can probably spot the Duratrack sleepers there.
Yep.
At the station. So that brings us to a wrap for our innovation showcase. So if you've enjoyed today, definitely come along to the ecologiQ conference in Trade Hall. You can meet not just our presenters here today, but other businesses as well. It really is, I reckon, the best opportunity throughout the year to connect with a lot of these businesses. So that's September 18 to 20. All of you who've found your way onto this showcase and webinar can also have access to our Knowledge Hub if you haven't already requested. So the Knowledge Hub is a treasure trove of information. So we have case studies, visual guides, reference guides to the standards and specifications that let you use recycled materials in rail, road, and ancillary infrastructure. We'll soon have a database where we've captured all of these innovative materials that have been presented on our showcase, along with other ones that we're actively working to implement on projects. We have a supply map, so you can actually go and find manufacturers if you're in procurement or you're looking for local suppliers, and that covers both Melbourne Metro and regional Victoria. So a ton of information. Please get onto our Knowledge Hub and follow us on LinkedIn. This recording will be uploaded on YouTube. If you have any queries, sorry, it's been clipped at the bottom there, but you can reach out to us at ecologiq@roadprojects.vic.gov.au. I've noticed there doesn't appear to be any questions for you, Paul, so you must have captivated and answered any queries that people may have had.
I'm so efficient.
So without further delay, thank you everyone for dialing into our showcase. We'll resume these after the conference. I think October is probably when we look at the next one. Thank you again for dialing in, and enjoy the rest of your day.
Thanks, Doy. Thank you.
Thank you.
Thanks, everyone.
Thank you.